And welcome to the webinar, Become 75% Faster at Your PPAP and APQP Processes. This event, brought to you by Quality Magazine, is sponsored by HiQA. I'm your moderator, Daryl Sealand, Editorial Director of Quality. Thanks for joining us. Today's presenter is Tim Hogan, Vice President of Business Development at HiQA. Don't forget to submit your questions, and later in the program, our presenter will address as many as possible. Today's event is being recorded and archived on QualityMag.com. And now I'm excited to turn it over to Tim Hogan.
Well, thank you very much, Daryl. And thank you everyone for joining us today. So your time is very valuable and we are not about to waste it. So let's jump right into the message and get to automating your submission requirement packages. So we're going to present a slightly different format today. Typically, we'd run through a PowerPoint presentation explaining the process and how we can help fix the bottlenecks. However, today we're going to take a step back and just introduce the concept of what we're going to be addressing. And then we're going to spend the vast majority of our time with a live presentation of the software itself and our PQP application. Now, we hope you don't mind the change, but we thought you might like to see the product in action and how it can actually streamline your process. But is 75% a realistic number? Well, we typically state that you can save at least 50% of your time. However, our customers do tend to tell a different story. It's not uncommon for our customers to see a 75% time savings from their existing process. Okay, we know we all get acronymed to death in this industry. However, it's important to note that although there are different forms of terminology across industries, many of the requirements are the same. A PFMEA is a PFMEA, whether it's part of a device master record or an AS9100 package. Whether you're in medical, aerospace, automotive, construction, or even defense, most have adopted some form of quality system to address some, if not all, of the original 18 elements. But why do our customers need help? Well, let's consider an example. How long do you think it would take to create a CNC process for this part, including tool selection, creating tool paths, cutting the part, and everything else from start to finish? When we asked the CAD/CAM people this, they said, about 2 hours. Now, the beauty of that system is that it's all contained in one single system. So how long would it take to balloon this print, extract the GD&T out to create an inspection plan, assign the inspection tools, collect actual results, create reports, compile gauge R&Rs, capability studies, control plans, PFMEAs, and everything else? Roughly speaking, about 10 hours. So that's about a 5-to-1 ratio. Something has to change. Well, what we hear frequently from shop owners or plant managers, it usually goes something like this. Look, I can add machines, I can add production, I can add capacity. I can even buy robots to load the machines so I don't need as many people on the shop floor. Where I'm struggling is finding people and resources to complete all the documentation needed for PPAP submissions. And quite honestly, they're stuck in a quandary because if they add more people to do paperwork, this typically adds to the overhead cost and makes the piece price go up to where they may or may not be awarded the job. But if they don't add the people, they run the risk of not shipping on time and therefore potentially losing business or future business because of missed shipments. And in our current times, we could also add the availability of employees. I just read yesterday that for every person looking for work, there are 2 job openings. The ability to add qualified employees and retain them is becoming increasingly challenging and putting further strain on the overall system. But why has so much focus and emphasis been placed on streamlining the manufacturing process and making the parts better, faster, with more robotics, automation, and process control, while very little has been applied to the quality documentation side? What if we could automate the documentation portion of the PPAP submission? That's where we come in HiQA's PQP application. So pardon the play on acronyms, but PQP stands for Production Quality Planning. So no matter the industry or sector, if you're producing a part, you need to prove that the parts you make and the process you made them in meet certain criteria, and you need to document it. From a 2D print all the way through manufacturing and submission, we can help control your process digitally. That's right, this is not a file management system. We are not uploading forms and keeping track of them. This is a database-driven solution that provides complete transparency of the part record, and it increases collaboration between your departments, which you'll see, especially the manufacturing and the quality departments. And when we get into the software here in just a second, what you'll see is we're going to break this down into different sections. While we focus on the PQP, which is in this slide in the reporting and submission section, it needs to start somewhere, so we need to build a few foundational elements. The part and job planning we're going to start with, and then we're also going to roll into the data collection side of it to show you how you can automatically grab the data from like an automated measurement system and import it directly in, or on the shop floor data acquisition side, like manual checks, for example, we'll bring that information in, and all of that information is going to be populated in the database and available real time for you. Now, we want to build that foundation because we need to do something with that information once it's in the database, right? We need to create a report, run statistics, build our APQP documentation and submission package requirements. And so we're going to build some foundational elements that roll into the PQP. So we're going to come back to this a little bit and kind of notate the 3 different sections and where we are in the process. But I promised to be short and not kill you with a PowerPoint, so I hope I did that okay. But let's delve into the software and show you some PQP applications. Let me share my screen here. So hopefully you can see the screen okay. So what we're going to do is we're going to open this part up like it's brand new. So we're just going to say new from drawing, and we're going to pull in a sample print here. And please note this is a 2D PDF. We do support 3D models that have the embedded PMI information in there, or model-based definition as it's called. So we do support that, and we can extract that information from the model automatically. But still, even though we want to get to that 3D space eventually, most of our customers, and most of customers in general, still start with a 2D print. So the problem with a 2D print is it's kind of a dead document, right? It has just information on it, but it's not actionable information. So we need to redigitize it to make it more accessible so it can be actionable. And we simply do that by having an auto balloon function right here. We're going to single click on this. And there's different options, for example, pages or basic and reference dimensions you can turn on and off. But we're simply going to come down here and hit OK. Now our proprietary OCR takes over. Optical character recognition is what OCR stands for. And what it's doing is it's reading this print and figuring out what's a dimension and what isn't. And then it's going to, most importantly, apply that information directly into the database. So we can see that took approximately 25 seconds or so. All of the data has been analyzed and it's been fully ballooned. But more importantly, if we look down into what we call the bill of characteristics, all the information's already been extracted and in the database. This looks like a spreadsheet, but it's actually a table in a database. And certain things have happened already. We've already assigned some sampling rules, and acceptance rules. And it has notated, please also note that we do identify if there's a multiple place dimension, and there will be space in the database for all 8 requirements, not just one. So we did all of that in approximately the first 25 seconds or so that we ran this. We can also do additional extraction from the print, being we have this really cool OCR. We try to take advantage of it as much as possible. For example, if we come up, we have an extract title block text. I can grab this information. All I'm doing is box selecting and letting go and saying what it is. This is the part name. And if we look up here, we can see our part name is now updated. So we can grab that information as needed. I'm skipping over a few things because we definitely want to spend the vast majority of our time in the PQP application. But again, this is setting the foundational elements required for that because everything pretty much starts with a print. We have a really neat tool here called whiteout. We can white out dimensions so that you can easily see anything that gets missed. We do not claim to be 100%. We certainly will miss things. But as we're looking at this, some of our customers need to balloon notes as well. And let's say, for example, these were notes. We have a balloon note function here to where we can simply box select it just like we did the other ones. We're going to sit here and box select this and let go. And now it's parsing the information over on the side. And we can see if this is correct or not or what have you. And you'll also note that if you click off of here, it now disappears because it's part of that whiteout function. And if we grab this one as well, we can see it also numbered that, and that information is available on the right side as well. Now I picked those two out purposely because if we turn these off, we can see that they are dimensions number 43 and 44. It added it to the end, okay? So why did it add it to the end? Because at this point, we don't know if this is an engineering change, if it was, accidentally missed, we don't know. Now, being we're still in the planning phase, getting back to our circular diagram, being we're still in the planning phase, we're building the information for all this, right? We're building the database. So we can simply come up here to our renumbering and click a button and everything gets put back in line, not a problem. Now, if we wanted to assign something specifically, like we have some customers that balloon all the notes first, what we can do is come down here in our bill of characteristics and say, lock these dimensions. And you'll see a little padlock come up. Now, if I go to renumber these, it'll say you have locked dimensions in the list. So it kept those as 1 and 2, and then you'll see what used to be number 1 is now number 3. Okay, so we can have different ways to renumber them, whatever makes sense for you. We do have the functionality to be able to break dimensions out. What do we mean by that? So if I single click on this, if we look down in our bill of characteristics, we can see that it did recognize it's a 2-place dimension. As we get into collecting this data, you'll see that the database is looking for multiple place dimension. It is looking for 2 sets of data points to be able to put in here. However, if we want to uniquely identify them, we do have a button over here called multiply out, and we can easily identify them uniquely to say this is _1 and this is _2, and it's been broken out into the bill of characteristics as well. If we don't want it, we can simply reset it back and put it right where it was, but just a couple neat features of it. Okay, let's get into a little bit more of the guts of the software and as it applies to PQP and building our APQP information, okay? Because what you'll see later is we're actually going to generate the PQP documents automatically. It's pretty cool. But how do we get there? So let's just take a random dimension. Let's take this radius and say, all right, how do I want to measure this? Let's take an angle. Maybe it's a little bit better. So how do I want to measure this? Now, keep in mind, we're still in the planning phase. So this is like a quality engineer maybe doing this. And they could come in over here. And in this characteristic, in dimension number 19 characteristic, they can say, how do we want this to be measured when it comes down the pike or comes down to measuring it either in quality on the floor or what have you. let's say, oh, I want to use a contour tracer to measure this. And is this a characteristic designator that's important to you? Meaning, is it a CTQ? Is it a major, a minor, a flight safety, a KPC? What is it? Some type of key characteristic. I'm going to hit save. And then when I do, a couple things happen. Okay. We do have a designator column down here in our bill of characteristics. We have a gauge category. We can see that we're saying, please use a con tracer to be able to use this. But I also have a rule set up in my system that says if it's a key characteristic, automatically change the sampling rule to be based on an AQL table instead of the default. In this case, the default was set up at 1 per lot. So you can set up the default to be whatever you want. But more importantly, when we start talking about rules in the system, we can set up rules for features or rules for characteristic types. So in this case, we said, okay, characteristic designator is a key characteristic, so it's going to be AQL based. Hypothetically, we could say if it's a diameter, automatically make it a CTQ and apply an AQL C equals 0 table to it. No problem. So that's how we streamline, or partially how we streamline things, because we can set up rules in the system so it happens automatically and you're not having to go in and manually change it. However, if you do need to go in and manually change it, let's say this 203, for example, we want this to be not 1 per lot, but maybe 1 per hour or 2 per hour even, okay? And we hit save and close. Now we can see that's set at 2 per hour. So when a job comes in, that information and those samples will be automatically generated based on the number of samples needed to satisfy this sampling rule based on the job that's imported. So all that information can be tracked right here. Now, I bring that up because we're starting to roll into the control plan already, right? So in the control plan, we have the sampling rules, we have gauge categories, we have ways that we have to state on the control plan of how we're going to measure it, how frequently we're going to measure it, and items like that. So later on, it's automatically going to bring whatever information we have here into the control plan. We're already starting to build our process because it's all tied together. So just wanted to mention that. Also, speaking of gauge categories, we won't spend much time on it, but just wanted to introduce the idea that we do have functionality in the system already in our core software. So this is not an add-on, as a gauge management package. So we can manage all the gauges in your facility, calibration, due dates, certificate numbers. What most of our customers do is they have like a third party come in and certify it. They'll upload the attachment here, update the date, and everything's logged and traced. So we even have a tracking log right here to say, okay, what has happened? Obviously, nothing's happened here. But why do we have all of this information embedded in? So as we get going in a few minutes here, what you'll see is we're going to start acquiring data and bringing it into the database. Well, what we can do also, let's take this thread gauge, for example. A function we have that we don't believe anyone else has is if we look right here, we have usage history. If I click on that, what we're seeing is every single dimension that gauge has ever checked, right down to the job number, the lot number, the serial number, the dimension it checked. If we scroll over, you'll know who checked it, time and date stamp. If it was tied to a specific machine, or if it's a plastic injection mold, maybe it's tied to a specific mold or a specific cavity in that mold. If it was tied to a non-conformance record, we can track that as well, and we'll get into non-conformances in a couple minutes. But all that information is readily available because we're all sharing the same data in the same database. So wanted to, again, there's more creature comforts here like notifications, and we can import your existing list. But we want to kind of skim over that and spend most of our time together in the PQP side. But in order to get to the PQP side, let's talk about manufacturing operations, because that's quite frankly, a vital element of it. So if we go into manufacturing operations, our screen changes a little bit, changes color, just tells us we're in a different location, a different spot in the software. But let's zoom out a little bit. So what we're doing, so how are we going to make this part? We're not going to come in and chuck it in a lathe. Maybe you could, I don't know. That would be difficult. And just spit out a part, right? It's going to go through operations. We have drilling, we have milling, we may be roughing it, we may be doing different things. So what do we want to measure at what stage of the manufacturing process? And that's really what we're going to identify here. Let's say these dimensions are affected by operation 10. I'm just going to select them, click on operation, and maybe it's a size cut for all I know. I'm not worried about relevance right now. I'm just trying to show you some some ideas. Maybe these dimensions are in op 20, and these dimensions here are in op 30. And maybe op 20 is we're drilling it. And maybe op 30 is milling. Something along those lines. So you can keep going and keep going. However, now is where we start. We were talking before about collaboration between quality and manufacturing. This is one of those first steps in which we can collaborate interdepartmentally. What do we mean by that? Well, a lot of times when you start building things into operations and making check sheets for each operation, that's done by the manufacturing engineer, not the quality engineer. Typically, not always. But right here, one of the challenges with that, backing up for a second, is that they're usually fairly siloed, right? Manufacturing working in their realm and quality's working in their realm, and then they don't come together until the end of the process. Whereas now they could come together in the middle of the process, right? I'll show you what I mean by that. If we look down here in our bill of characteristics, we see we have a manufacturing operations pull down. If we can only look at, let's say I just want to look at the milling operation, we can see that these are the two dimensions for the milling operation over here, op 30. If we zoom in on this, we can see that, oh, these two are only affected. What we'll get to in a second is how we get information from them. But let's just say we need to change something about these two just in this operation. We can do what's called an update these. Now, if you look, we're only updating the op 30 portion. Maybe we want to say, hey, measure these with a height gauge. You wouldn't, but anyway, you get the idea. Or let's be relevant. Okay, I think we have an optical comparator in here. Optical comparator. Maybe we want them to be a rhombus balloon form. Maybe we want to change the tolerance to plus or minus 50. Whatever we want to do. Another thing you can do, we're getting into sampling plans a little bit here, is you can change the sampling plan for this to maybe be, let's say you want 100% check on these. You can change the sampling plan for this operation, not the final inspection. Because if I hit apply and close, we can see that our symbols have changed here. We're plus or minus 50 on this. And, oh, that was an angle, but that's a plus or minus 50. And our sampling plan is 100%. So we can change things right at the operational level. And again, that's usually done by an ME. The neat thing about this is we're all in the same database so that all of our numbering, even this is still number 3 and still number 7. So all of our numbering is still consistent with our final product and our final finished, the finished part that you see here, number 3 and number 7. So everything is starting to be correlated and tied together. But now we need to measure this, or excuse me, make this part so then we can measure it right on the floor. How do we do that? Well, we have a product in IME called IME-IMX. So right now what we're going to be looking at is Explorer. And we're going to log in here. I'm just going to log in using a generic. We do support scanning badges if you happen to have a badge system at your facility. Now, here's a good example, before we get into the data itself, this is a good example of the power of a database-driven system. So when we were in here, you saw me go into measurement gauges and look at the full gauge management library that we have. Well, that same library is now available on the shop floor. if you happen to have gauges that maybe they go into a gauge lab and check in and check out, let's say you need a depth gauge, for example. They can go in and say, okay, here's my depth gauge. Maybe I'm using a blade micrometer and that's in the manufacturing facility I'm in. They can check this gauge out. It has most of this information already because it's pulled from the database. They can simply say where they're taking this gauge to, say check out, and now it shows as checked out and where it is or who checked it out, right? And they can simply put it back to the storage space and it's back where it belongs. So all of that information is available real time because it's in the database. Now, taking a step back and looking at Explorer for just a second here, this is a browser-based application, right? So we are in Google Chrome. If you notice down here, we're just in Google Chrome. This is going to an IP address that is in your facility. So when we talk about a database-driven solution and how it works, please note that this is an either on-premises or on-prem, sometimes it's called, solution to where the database is in your system. So if you're asking how secure is it secure? It's as secure as your IT system is because it's not leaving your premises, okay? But for entering data in, usually, oh, I'm sorry, I forgot to mention something. So being this is a browser-based application, it can be used on anything that supports Chrome. If you have an iPad or a tablet, some type of tablet, maybe Microsoft Surface, if you have a computer workstation, whatever you have, this will work on and have different applications associated with it or different benefits. Maybe you want an iPad for portability, maybe you don't you don't want your iPads walking off. So whichever way you want to handle it. But you can, if we go into gallery search, this just gives us a quick view to see what jobs are in the system and what I'm working on. You can select it by different elements up here. For example, if you know you're working on this specific job, you can go into this specific job and it gives us a nice dashboard to know if it's complete, if there's any good or bad dimension or any bad dimensions. And once we go into this, here are all of we were talking before about building samples, right, based on a sampling plan. So based on this job coming in and the sampling plan, it built all of these unique part samples. So if we go into this sample, for example, and here's our manufacturing operation up here. So this is, you're looking at a finished part right now. So you could enter information for a finished part, or you could go up to that milling operation that we had before. And here's our milling operation. So now I can add information right on the shop floor. And again, this is meant for more of a simplistic look, shop floor data tools that are more manually entered, right? That's the idea behind it. And we can just, this is a very flexible system. You can pan it around, zoom in, zoom out. It gives you the information over here to be able to include in. However, if you want to just expand the view, you can simply do that to make it more user-friendly to see. Now, here is where we start tying that data together. What do I mean by that? Well, we talked about the gauge information all tied together, and we know every dimension that it checks. Well, this is how we get that information. So we had optical comparator checked, right? Well, now it only gives us a list of the optical comparators instead of a list of all of the gauges in the facility. So I can simply come in here and say, I'm on the Starrett, and now I'm going to enter this information in and hit accept. It's live in the database. So once it says okay, it's going to turn green and go on to the next one. Okay, automatically toggles through them. You don't have to go and select them manually. You can if you want to. But also notice this is a 2x dimension. And also notice we have two different spots to enter it in the database itself. This keeps saying control because how I get that circle is I hit control on my keyboard. Because this is listening. We do support RS-232 out, Bluetooth, wireless, all of that functionality as well. But let's say this is 0.28. We hit accept. It's actually on a spec dimension. So instead of us writing down the wrong number, entering in the wrong information, it automatically prompts us to say, hey, wait a minute, this is out of spec. Do you want to measure it again? Maybe the caliper was zeroed incorrectly, something along those lines. But let's say it really is bad. If it is bad, we would say keep failed. Once we do that, it'll automatically pop up with a non-conformance record for us to fill out right at the point of failure. And they can simply say, okay, I'm going to add a new one, power the database. It has all of this information already. Unique number, and this is configurable, whatever you want it to be. We just need to say, hey, this needs to be repaired. Maybe it's scratched. Oops. And if we hit OK here, maybe we need to say, okay, where was this? Maybe it was in the joining phase and two things were, welding or something along those lines. Now that nonconformance was just entered in the system. I point that out because we have notifications set up in the system to where people can be notified if a nonconformance is created. So imagine if nonconformance is created on the floor, just like this one just was. You get a notification and you can log in here and be able to see that nonconformance right here. We won't get into that now because we want to focus on the PQP, but just note that we can have notifications set up to do that, okay? So getting back into the data here, the last thing I want to show is, as far as the data acquisition goes, is the what we call AMDI, or automatic machine data input. What is that? That's a big word, or lots of words together. That's automatically bringing in information from like a CMM or a VMM or an ARM or a tracker, some type of automated measurement system. Okay, and what would that look like? So I'm going to kind of simulate that here, okay? This isn't how it would be brought in, but this would represent like the raw data from your CMM. So your CMM would save it to a file folder somewhere, and we would actually bring that information in automatically. So that what I'm doing right here, you wouldn't have to do. But once you hit import, now that information is going to be imported and automatically overlaid right on the print itself, because we can see that here's all my samples that I have that have been brought into the system, okay? So we have all this data. And this is a good thing to note to say, hey, well, how does the data get brought in? As additional samples get measured, they simply get added to the bottom here, okay? So we can look and see that we have all good checks and we have one out of spec condition. And even at this point, we could say we need to add a non-conformance report for this specific dimension. You can tell it's a little different look. So this is more of an engineering feel than a shop floor feel, right? So we can assign it to certain people. We can email it right out of the system. And why would you want to do that here? Because everything is logged and tracked in the database. Everything we do here is completely traceable. We have change logs. Everything that's done here is logged and tracked and traced, okay? But now that we have the data, what some customers do, or in some limited spaces or applications, excuse me, is to like create a report from this. But a report is simply a part of a submission requirement, right? So if we simply go into our submission requirements, what we call our PQP records, we see we have an FAI report here. So when people say, hey, I need to create an FAI report, why? It's part of the submission package. It's automatically generated right inside of the software itself. For example, if we go into the FAI report, we can see, and by the way, this has not been submitted, right? We're still in, we'll get into workflows in a minute, but it's still in what we call a draft phase. And we can enter information in here. Here's some of our measurement data that we have. We have spots for signature. I was testing the signature. You can see the time and date stamp there. All that information is captured, and it's part of the database. So we don't need to, hey, let's save this file, kick it out into Excel, and put it into a file folder somewhere to retain it. It's already retained. It's already part of the submission package, okay? So let's get into this a little bit deeper. And we get into it by going back to manufacturing operations. Because when we go into manufacturing operations, this is exactly where we were before, but in this file, we have processes identified. So something we didn't get into before, here's that milling operation, for example. Something we didn't get into before, we renamed it milling, but I purposely bypassed this, but I bypassed the process pull down, because what we've done and what's in here is we've taken all the information for your process and we've templatized it. We've digitized it and it's in the database, so that all we need to do is select the process that we need, or that's part of this manufacturing operation, and we'll automatically bring in all of the information associated with that process. The flow step, right? The process flow step, the PFMEA failure modes, it'll bring all those in. And I'm going to show you how those work here in just a second. But this is the only thing you need to do. Now, I'm going to come back to this and kind of show you what that would look like in practice. So we'll come back to this. But once we identify those processes, we go over to the PQP records and we can go into the process flow, for example. And we can see here's our process flow that was generated. Okay, here's our milling step, for example, and the different steps associated. We can go back to our index. And by the way, our index is our list of requirements as you see it here. Okay, and I'm going to show you how to build that index as well. It's pretty cool. But we can go into our process. Oops, sorry, I clicked on the wrong button. I meant to click on the PFMEA. We can go into the PFMEA. And here are the failure modes. This is a live document, right? Because it's part of this unique part record. So what we said is, hey, identify the process, and it's going to pull in all of the templatized information into this unique part record, right? But now that it's part of this unique part record, it can be modified and tweaked unique to this part record, right? Because a lot of customers will do that. I was with a customer yesterday and he's like, hey, we have a generic one that we bring in because they're a medical company and they do a lot of lathe work. So they're always turning something, and we have kind of he was saying they have a generic turning failure modes that they bring in and then they tweak them per part. This is exactly what we're talking about. It'll automatically bring in that template, but now you can say, oh, this isn't a 2 occurrence, this is actually an 8. Okay, great, it's an 8. Now that information has been updated and automatically generated, the RPNs recalculated, the labels here are updated automatically, sorry, not naturally. So all of that information is tracked and logged and available in the system. And if you need to change anything, you can change it here. It's completely configurable, okay? Now, speaking of changes, let's talk about that for a minute, because we have different levels of changes that need to be applied, right? Meaning somebody needs to go in and do this, put eyes on it and take a look at it. If they need to change things, not just anybody can change it, right? You have to have permission to be able to do it. So we can get into roles and permission levels within those roles in the software. However, once you have the role and you're set up properly, we go into what's called a workflow. Okay, and now let's talk about that for a couple of minutes, because this is a very, very powerful aspect of the PQP application. Because if I could talk about it from a different aspect, it not only relates to PQP, you can use a workflow for anything in the software. All right, so let's talk about that for a minute. What does that look like? So we have a workflow built up for this FMEA that says, okay, it needs to be drafted by this person, reviewed by this person, signed off, complete. This is the workflow that we established for the PFMEA, okay? So we're in this phase right now. So as long as you're identified as a QC inspector, this person who's identified here is going to fill this information out. So there's 2 different levels here as well, right? There's a QC inspector. Well, can any QC inspector go in and do this? Not necessarily. They would need to be assigned here, right? Maybe I want Joe to do this. And so we can just hit save, and now Joe can do this as well. Or, Tim can do this. But if I had multiple people in here, this wouldn't be me, this would be somebody else. But they need to be identified as the owner, right? You can have multiple QC inspectors, you can have multiple QC managers, but they need to be identified as the assignee so that if this gets approved or rejected, it knows where to go. Because if I submit this, it needs to go to the next step. So what will happen is that when you have this document that's modifiable, right? It's editable. When we hit submit, it changes this to be uneditable. Think of it like a PDF, embedded PDF. So then it goes to the next step in the workflow for approval. If it gets rejected, it changes back to an editable form, and then you could put notes on it as well. And it says, hey, fix this. This is wrong. Look at this again. And then this same process would work. Okay, meaning it would be kicked back to them for approval and then sent up the chain for signatures. So everything that's done in here is logged, tracked, and traced. You'll hear me say that several times, because if I look at the history of this, here's all of the workflow change that was done that I just did today. Here's 6/1, right? That's actually today, just now. We can even look at minor records to see when things were opened or closed. Everything we do is in the database, even certain revisions or even signatures that are in the system, okay? So let's go back to the index and let's talk about this for a minute, because indices are very important. So if we say change index, what does that mean? You can have different levels of submission requirements for different customers in any way, shape, or form that you want them, okay? For example, maybe your 9145, these are all of the, submission requirements needed for the 9145. Maybe you're working with SpaceX and they need a level 5. Well, they need all of this. Well, maybe they only have a level 3. Well, they only need this, right? So they only need a few of these documents or requirements. So you can have as many indexes as you need. And, there's only 4 here. If you need 20, make 20. It's completely configurable system. And maybe if you're doing this, I'm like, oh, I only need an FAI to, submit this to Stryker or whomever. So you can build any index you want. And I can show you, if we have time, where you'd actually build those indices, okay? So what would this ultimately look like in application? So let's go back to our manufacturing operations, okay? I'm going to take off this sample. So let's say, we'll go hypothetical. We get a complaint from the customer that says, hey, these dimensions are bad, or you're having struggles with these, check them more frequently. And you get together and say, hey, our corrective action is we're going to create an operation at shipping to where we measure them. Okay, great. So we can select them. Oops, we're in our manufacturing operation over here. Let me pull that up here so you can see it. There we go. So we'll grab these dimensions and we're just going to say add operation. Okay. So now we have an op 60 added, and we can see that the colors have changed here. And we're going to click on our little pencil, and maybe we can assign this to a specific work cell. You can assign it to actually it's not a machine. And we can assign it to ship parts, let's say, for example, and maybe we'll call it shipping. We'll say, okay. So all we did was type in shipping here and assign it to the process of ship parts, right? Now we go back to our PQP. Now, as mentioned before, or maybe I didn't mention it before, everything is tied back to the process flow diagram, because you can have additional things in the process flow than is in the manufacturing operation. For example, ordering materials, storing a warehouse, that's not a manufacturing operation, but it is an operation, or it is a process. So we do have the functionality here to add non-manufacturing processes, okay? However, we do have a change in the manufacturing operation, and we know that because we just did it, right? So we're just going to go up to sync processes. What that's going to do is it goes into the manufacturing operations, looks for any changes, and automatically brings those changes in. And it's going to bring it in a form that you can, or any location, and you simply click and drag it exactly where you want it. Let's say it's the last step, okay? Automatically renumbers the operation. And then we're just going to hit apply changes. Yes. And now the ship parts is part of the process flow. Okay, we just added that. So we're going to go back to our index, and now we're going to say, hey, how does that affect the PFMEA? Well, we'll go into our PFMEA. The PFMEA gives us a note that says, hey, the process flow has changed. Please synchronize your processes. So this is where it gets pretty cool, because what we're doing is we're saying sync these processes. It's looking at the process flow, seeing that there was a ship parts added to it, goes up to the template, grabs the ship parts process and all of the failure modes associated with that ship parts, and automatically populates the PFMEA. Okay, we can simply say apply changes, hit OK, and now that ship parts becomes part of the PFMEA, and we can change things here. But remember, we're changing it at the part level for this specific job, not the template level. Okay, we're not changing the template. So where this gets really, really neat and where things really start to tie together is in the control plan. Let's look at the control plan for a minute. So we get the same error message, right? The process flow has been changed. Please synchronize your processes. So we say, please synchronize your processes and dimensions. What it does is that it does the same thing, right? It goes to the process flow diagram. It sees the change, but now it says, I have a change. I'm going to go back to my manufacturing operation and bring in all those 5 dimensions that I selected in the manufacturing operation and automatically bring them in to the control plan. Additionally, we have all of the criticality already outlined that we identified when we were building the sampling plan. Plus, we have all of the information from our sampling plan is automatically brought over, right? Plus, whatever we identified as the unit is the measurement tool automatically comes over. So that's where all that information that we populated is already generating our control plan, as opposed to us having to go in and remodify this again. I used to do PPAPs a lot, and this is literally a game changer for me, because, oh my gosh, this would save so much time compared to having to go back and change all of that documentation in the Excel spreadsheet all the time. So now we have that, we can hit apply changes, we can hit yes, and now ship parts in these 5 dimensions are part of that control plan, okay? So let's talk a little bit more about, and I know I'm hitting you with a lot of stuff, I apologize for that, but when we go back to the index, so what does this look like from the other side, meaning for other submission documentation requirements? Let's take the submission warrant, for example. And this is a good example of a document that's already in the process. So this was filled out, okay, as much as it could be. You can tell there's no yellow, so there's no nothing that can be modified or added. If we look in the workflow, you can see that we're at the review stage by the QC manager, okay? So you can hit approve and reject, and if you approved it at this point, it would go to the signature stage to the procurement manager. If you hit reject, it would go back to the editable form and back to the QC inspector, okay? And everything is done in the workflow history. Everything is tracked in the history itself, okay? So whatever the documents or the submission requirements inside the package are tracked, and then the submission package in whole is also tracked, right? And if there happens to be any signatures associated with it, actually, I think I have one here with a signature that actually works quite well. I think it was the AS9102 report. And we look into signatures. Yes, we can see the signature certificate, the ID of it, what the document name is, the recipient, timestamp, what happened. Everything is logged and tracked and traced, okay? So the other side of it, I do want to present just very, very briefly, okay? And because I know we're running short on time, so I want to leave some time for Q&A. So I just want to show you where that information came from. So we talked about, hey, it goes and grabs it from, grabs all of this templatized information and pulls it in, right? So now we're going to get into more of the system side of it, not the unique part record or the individual part record. So where does that go? It goes in the library, right? Makes sense. We have a bunch of processes. We have a library for them. So here's that milling operation, for example. Now, when we selected milling, or actually, let's pick the ship parts. So we did that last, right? So when we picked ship parts, it came up with a process type of move. It didn't just figure ship was part of it. It looked to see what was here and then automatically pulled that information in for the process flow. Similarly, our template Fmeas, when we brought in the ship parts, you saw all of the failure modes come in. These are the failure modes that it brought in. And if we change something at this level, you're allowed to, right? 6, change it to 72. So if we change it at this level, we're changing the template. So now it's going to be changed for anything moving forward. Any new submission requirement would be changed, or this new modification done. Now, keep in mind also, changing things at the template level where we are now is also permission based. Not just anyone can go in and change things at this level. And in addition to that, this is also part of a workflow to where you'd have to change it here and then send it through the workflow for a part of an approval process, right? Part of the workflow approval process. So all of the information here is synchronized with, I shouldn't say synchronized, but we use AIAG forms for this. So all of the AIAG standard forms come with the system. However, all the content, right? So if you're a plastic injection molder and you're mixing material and you're going polypro with talc or something like that, okay, what is that system like? Well, let's bring that information in from a source that I have already. We can import that information in. So that way, all your content here is populated. You're not having to manually enter all this information in, right? Because that would take forever. But the cool thing, even if you did, like hypothetically, even if you did, you'd only have to do it once. Then you're just modifying the database for all of the operations or all the processes. Okay, so. All right, there's more to show, but I'm going to stop right there because we want to leave some time for Q&A, and I'll turn it over to Daryl for a question and answer at this point.
Great. Thank you, Tim. Yes, as promised, we're going to go through and see if we can answer some of your questions that came in throughout Tim's presentation. First question is from Bill. Says, where does low come from in the last example next to RPN?
Where does low come in?
Where does low come from in the last
It's
example?
low, high, and mid. It's
like the low, high, medium.
Failure, yes. That's the question, Tim.
Yep, that's based on that's based off AIG, quite frankly. It depends on the level of RPN as to if it's high, low, or medium. However, that's also configurable if you do have unique customer requirements as well.
Exactly.
Okay. Our next question is from Jake. He asks, does changing the templates due to lessons learned update previous plans made?
No, it does not. And we really can't from a traceability standpoint. So a lot of this information is built around a submission package that you're submitting to the customer. So once you submit it and that gets approved, it's not good practice to go back and change something that's been approved.
Hey, okay. Hey, Tim, you guys able to hear me?
Yep, go ahead, Chris. Do you have something to add?
Yeah, sorry, joined a little late to help with some of the Q&A. Just something to add there, is if you make changes to the FMEAs, like a specific FMEA, you figure out how to, reduce the occurrence rating on a particular failure mode or something. But let's say it's not just for that particular part and job. Let's say it's across the board. You figured out for that failure mode on any part that applies to. and you want to apply that to your master templates, you can do that and modify the master template based off of an individual FMEA that's been updated. So it affects going forward as opposed to historically.
Mhm.
Great. Next question is from Eric. He asks, can an improvement be made out in the process that is then pushed to all of the FMEAs and PCPs that have that process contained within them?
Actually, Chris, I think
Yeah,
you were
so I
just
think
working with
that's,
a customer on this. You'd be a great person to ask.
yeah, I think that's about the same question though, is yeah, that you would want to affect FMEAs going forward, but for active FMEAs, you would want to manage those independently.
Okay. Our next question. Does IM Explorer allow suppliers to log in and enable them to input actual measurements?
That's a big question, and there is a big answer. This is Sam. Can you hear me?
Yes.
Team Chris? Okay. Yeah, we have a module that supply chain management. This is a big module that's require another session for 1 hour. But yes, the idea is that the PQP, if you will, the whole templatized data, all the optimized templates are the communication platform with suppliers. And then definitely when you enter data into it using the supply chain access or the what we call supplier success, then they are entering data either on a tablet or a PC or directly on your template, and then it gets directly to your database. I don't want to get into LAN and security. It's all taken care of, but there is a huge module that calls supply chain management that it enables traceability and connectivity with a lot of suppliers.
Okay, looks like we have time for maybe one more question here. And that is, what determines who gets notified on an NCR?
You do. That's a configurable field that you can notify certain people in certain situations. Like if it NCR gets modified, if it gets created, if it gets closed out, we have different notifications set up for that. So it's really up to you who gets notified and when they do.
Excellent.
All the questions that we don't answer, we will answer them, guys. So we will not leave you without answer. Sorry.
Well, yes, I would. No, that's fine. I was basically going to reiterate the same thing for our audience. There were quite a number of questions. You were all very engaged, which is impressive. But we will definitely answer your questions offline, the ones that we did not get to here in our live presentation. But that is all the time that we have. So please join me in thanking Tim Hogan and the rest of the team for their presentation, as well as our sponsor, HiQA. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. Please visit qualitymag.com/events for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience. Have a great day.